I guess it's all of the processes that run in the background. All right, let's see. I guess I can close that out, open it down here. Shall we start with 1?
Yeah, we're supposed to do odds. This is my homework for tonight. 1 through 19 odds.
Okay. Hold on. All right. Give me the
Do you
next.
have a person after this?
I'm sorry, what?
Do you have a person after this?
I don't.
Do you think we could go an extra 10 minutes since
Oh,
we
absolutely.
haven't started till 8:40?
For sure, for sure. I was going to do that automatically. So.
Okay.
Okay. So what's the next line going to be here? No, I just remembered. I have a student that's in your class, I think. And
Really?
I had her earlier today. Yeah.
What's her name?
Sarah.
Uh,
You know her?
I think so.
All right.
Vaguely.
I'd rather not give her name. I don't really make a practice of telling students that are in the same class that I tutor them. But I recognize these problems. These are the same problems she had. She says you're using a technique called substitution for these.
Yeah.
Okay? So that's the way we want to solve it, right? In other words, we have two choices. We could expand it out, or we can use this method called substitution. This is what I call a quadratic in disguise.
Okay.
We can really solve it by factoring without multiplying everything out. Because all we have to do is substitute. Use any letter you like. I like to use U. Do you use Z?
Okay.
Always let the substituted variable equal that middle thing right there.
Okay.
Okay? Now what kind of an equation is it in U? Becomes U squared minus 5U plus 4, which is easily factored. Factor that.
U minus 4, U minus 1.
So that's equal to 0, so U is equal to what?
U equals, hold on, let me finish writing this. U equals 4, yeah, U equals 1.
Now solve for x. In other words, now go back up to this equation. U equals x plus 3. And solve for x.
Do 4 equals x plus 3. Move the 3 over, and then you get 1 equals x.
Okay. And then the other solution, let's do the same thing. We get
1 equals x plus 3. Negative 2 equals x.
That's how you do these.
Okay.
Notice that that was a lot easier. We'd have come up to the same solution, but had I expanded that and distributed that and combined everything that I could combine, probably going to end up with that anyway. And in other words, no, I wouldn't. I would end up with x minus 1 times x plus 2, whatever polynomial results from that. But using substitution is a little quicker.
Okay.
So in the next problem, where we have
You could do u equals 2x minus 1.
That's the secret. And then what? What's our equation in u?
Um,
In other words, go back in and substitute u for 2x minus 1. What do we have?
would it be 4x squared? Is that
No. In other words, is all we're going to do is substitute u wherever we see 2x minus 1. So what does this become?
u squared?
Yep.
Oh, I see what you mean.
Okay.
Oh, okay.
That was a minus.
Yeah.
So that's u squared.
Minus 5u plus 4 equals 0.
Right. Now see how easy this is to factor.
It's the same thing as the other one.
It is, isn't it? Why did they do that? Well, because it gives you different answers for x. In other words, it's not the same polynomial.
Yeah,
It
that's true.
converts to the same polynomial after you substitution. But now we still have to solve for x. So what is x going to be?
4 equals 2x minus 1, 3 equals 2x, x equals 2/3. Or 3 over 2, 3 halves.
And
1 equals 2x minus 1, 2 equals 2x, x equals 1.
those are your two solutions. That's all we're doing. And in fact, every one of these, just take this middle term and let that equal to u.
Okay.
Okay, so on C, u would be x squared. So I would end up with u squared minus 5u plus 4 again. They've set these up so that they all end up with the same equation for u. I guess that's so you don't have to spend a lot of time factoring it. But
Wait, u equals x squared?
yeah. Always let u equal the middle term like that. So in this one, u would equal 1 over 2y.
What happens to that negative 5 in letter C?
It becomes u squared minus 5u plus 4.
Oh, okay.
Which factors the same way these both factored, only the difference is u is now x squared. So an answer of 4, what is x?
4 equals x squared. You could take the root, square root of both sides, and x equals 2.
Plus or minus?
Oh, yeah, plus or minus 2.
Why is that the hardest thing in the world to remember? I have been tutoring for 5 years, and I guarantee you that's the mistake made most by students. And I don't know why. It's just real hard to remember to put that plus or minus. And it makes a big difference because that's two answers. In other words, x isn't equal to 2. X is equal to plus 2 or x is equal to minus 2.
Yeah.
And
then the next one is 1 equals x squared. Take the root of both, square root of both sides, and 1 plus or minus, or x equals plus or minus 1.
So we have 4 solutions to this, right?
Yeah.
We should have 4 solutions. It's a quartic. You generally have the same number of solutions as you have degree polynomial. So if you only came up with 2 solutions, in other words, suppose we left off the plus or minus on both of these, and we thought the answers were x equal 2 or x equal 1, something's wrong. We only have 2 solutions, and we're supposed to have 4.
Yeah.
All right. Let's do only the odds. Oh, that is an odd. Good, because I wanted to do this one. So what is u going to be?
For 3a,
Yeah.
3a, u equals 1 over 2y.
Okay, so the quadratic in u becomes what?
Hold on. The quadratic becomes 2u squared plus 5u minus 3 equals 0.
Factor that. What do the first two terms have to be?
2u and u.
Signs have to be,
Opposite.
so we'll try plus minus, but also realize that it might be minus plus and it's different. So as soon as I have different coefficients, in other words I have a 2 here and a 1 here, that throws out the window all of the stuff that factors of 3 that subtract to 5 or factors of 3 that add to 5. Can't use that anymore.
I don't think this one factors.
No, it does. Only reason I know is because I did it earlier. So what I do here is I just start trying numbers. There's not very many factors of 3, so we'll try 3 and 1. That doesn't work. Right?
Yeah.
So let's try 1 and 3. And this doesn't work, but what does this produce as a middle term?
0. Wait.
Remember, do the two smiley faces. This is plus u.
Oh yeah, it produces 5u.
No, it produces minus 5u.
Or, wait, oh yeah, sorry.
Okay, and that is key because now we know we got the numbers right, we just got the signs wrong. So I go down here and change that to minus and that to plus. And that's going to guarantee that we have it right. Because now we get minus u plus 6u, that gives us plus 5u.
Mm-hmm.
So, now there's a couple of ways we can, I like the way we've been doing it. Let's solve for u.
Would u equal 1/2 and u equals -3.
Now let's solve for y.
1/2 equals 1/2 y. Do you just divide both sides by half and y equals 1?
Yeah, well, no. Y does equal 1, but I don't like that method of doing it. Notice y is in the denominator. That is not 1/2 y. That is 1 over 2y.
Okay.
So let's cross multiply and be safe. 2y equals 2, therefore y equals 1. Okay?
Okay.
Just not sure I like the way you did it. It seems to me that it could have led to a mistake. But, okay, you got it right, so I shouldn't complain. And then minus 3 equals 1 over 2y. This is a little harder to do in your head.
Could you cross multiply again?
Yep. So minus 6y equals 1. Y equals what?
No, y equals -1/6.
There's your two solutions. Y equals 1 and y equals -1/6. Now, no, we're fine. Well, what I was going to say was, do we need to plug these in and check to see if it's true? In other words, is there a possibility that one of these might be an extraneous solution?
Possibly.
Not normally with standard polynomials. Where you get extraneous solutions is when you see radical signs like 5b. We might end up with an extraneous solution there.
Okay.
Or this one here. Or when you see absolute value signs, you might have extraneous solutions. Or if you see logarithms, you might have extraneous solutions.
Okay.
By extraneous, I mean one of your solutions is not good. It doesn't work.
Okay.
In this case, let's try it. Let's just try. What does your teacher tell you to do? Does she say, check all your solutions?
No, she hasn't for this.
Okay. We're going to have to check 5b, because I'm pretty sure 5b produces an extraneous solution. But I don't remember 3a. I'm a little concerned because y is in the denominator, but I don't think that really matters. I don't think that's going to produce extraneous solutions.
Okay.
So let's not waste our time testing that. Let's go on and do some of these others.
Alright. 3b.
Okay.
U equals y squared minus 4.
So the polynomial is the same polynomial. I guess maybe they're facilitating our factoring. What did I decide? That was minus 1 and u plus 3. So our solutions were u equals 1/2 and minus 3. So what is y going to be? That's the first step.
Move forward to the other side would be the first step. I mean, you could take square root, but it wouldn't come out to a nice number.
No, it wouldn't. Did we make a mistake? Because I don't remember this happening earlier. I guess we're okay. So y is equal to what? Plus or minus the square root of 4.5.
So that's what you'd write?
Yeah. Well, or use your calculator if you want to convert that to a number.
Okay.
A decimal. It's going to be irrational, so I'm reluctant to take irrational numbers and convert them to decimals. For some reason, when I did that earlier, I got 9/4, and then it was really easy to take the square root of 9/4. It was 3/2. And I'm trying to figure out if I made a mistake here or I made a mistake earlier today. I must have made a mistake earlier today because this looks right. Okay, and the other u?
-3 equals y squared minus 4. 1 equals y squared, square root of both sides, y equals plus or minus 1.
All right, so 4 solutions. Again, and this is a quartic. Notice that if I were to expand this, I would get y squared squared, so I would have a y to the fourth. So I should have 4 solutions, and I do. Okay? Now, C is actually very similar to A. It's just written different. It's written with negative exponents instead of putting that in the denominator. What is y to the minus 2 equal to? Just in general, how can I rewrite that? It's the reciprocal. The negative exponent merely means it's the reciprocal.
That's what I thought. I just wasn't sure.
Okay. So, I don't have any problem writing it like this, though. What is u going to be?
1 over y to the first.
Yep. Or I can write it like this. Okay, so now my quadratic, again, is
2u to the negative second.
No. Remember that u is y to the negative 1. So this is 2u squared.
Okay.
Notice that if I want to find out what the squared term is, square both sides.
Okay.
Notice that when I square both sides, I get u squared equals y to the negative 2, which is what this is, y to the negative 2. So that's u squared.
All right.
Okay. So we get the same quadratic that we've been getting. We know how it factors. So we know that u is equal to 1/2 or negative 3. So let's solve this. Now, when we're solving it, it's better to write it like this. What's y equal to? And you can actually do this one fairly direct without having to go through the cross multiplying. The numerators are equal, the denominators have to be equal.
So y equals 2.
Uh-huh. And then the other solution would be minus 3 equals 1 over y.
Y equals negative 1/3.
Now, is this the one where this didn't work? Let's just test this just for the heck of it. I don't think this was the one, but I want to test it anyway. I can do it real quick. If I go back to the original equation and plug in 2, I have 2 times 1 over 2 squared, which is 4, plus 5 over 2 minus 3. Is that equal to 0? Well, this is 1/2 plus 5 halves. That's 6 halves minus 3. That is equal to 0. So the 2 solution worked. Let's try the 1/3 solution. 2 times 1 over negative 1/3 squared plus 5 over negative 1/3 minus 3. Is that equal to 0? What's this first term? What's 1 over this? What's negative 1/3 squared?
I don't know.
It's 1/9. In other words, negative 1/3 squared is the same as negative 1/3 times negative 1/3. Multiply numerators, multiply denominators, you get 1/9. And it's positive. Okay?
Alright.
So I can plug in 1/9 right there. Now what is 1 divided by 1/9?
9.
Okay, so let's plug in 9 there. What is 5 divided by minus 1/3?
Negative 15.
So now we have 18 minus 15 minus 3. That's equal to 0 also. So both solutions worked. Since we don't have much more time, I want to do one more. I want to do 5b.
Okay.
Let's do 5b. What is u equal to?
5b. U is equal to square root of x.
So our quadratic is what? If u is equal to the square root of x, what is x equal to?
U squared.
That's our first term. U
So
squared.
it's u squared minus 3u minus 4 equals 0.
Which factors into u minus 4 and u plus 1. So my solution is u equal 4 and u equal minus 1. So let's solve for x.
4 equals square root of x. Could you square both sides to get rid of that square root sign?
Yep, so that's one solution.
And then negative 1 equals square root of x. Same thing?
Right, only here is where the problem is going to be. Both of these aren't going to work. Let's go back to the original equation. It's because we have a radical sign in there. X minus 3 radical x minus 4. So let's try 16. 16 minus 3 root 16 is 4. That works. But now when we try 1, it's not going to work. 1 minus 3, square root of 1 is 1, minus 4, that's not equal to 0. Therefore, this is an extraneous solution, and the only solution is x equals 16. Be careful. Be careful on 7a. It's going to be the same thing. There's a radical sign there.
Wait, 7a?
Excuse me, 9a, or just 9. In other words, wherever you see a radical, make sure you check your solutions.
Okay.
Or when you get into absolute values and you're solving absolute values, check your solutions.
So on just 9 real quick, so u would be equal to the square root of x.
Yes.
And then it would the term would be u squared minus 11u plus 30 equals 0.
You got it.
All right.
Every one of these is exactly the same. In 13, u is 1 plus x over 2.
Okay. Will this video be uploaded tonight?
Not tonight. It takes a couple hours to process. It'll be there by the morning, by like 7:30. It probably doesn't do you much good because I know you probably go to school by then. But I
Yeah.
don't have any choice. These GoToMeeting files take a long time to convert to WMV files, which is what you
Okay.
look at. Okay? I'll try to get it
Okay.
up there. If I'm up for a couple more hours, I might have it up there by tonight. I'll get it up there just as soon as I can.
Okay, thank you.
All right? Okay, Jackson.
Alright,
Let's see. We have another one Saturday?
tomorrow.
Tomorrow? Oh, that's right. You moved from Tuesday, Wednesday to Wednesday, Thursday. I'll talk to you tomorrow.
Alright, thank you. Bye.
Bye-bye.